Okay, here we go. This is, to me, the real part of looking at statistics. This is kind of like the introduction to it, and I'm hopefully going to do a good job explaining this to you. My apologies if I don't. Okay, how do you find the range and deviation for the set of data? And when I say mean deviation, what does it mean to us? How does it make sense to us? If I tell you to find it, what does it tell you about it tells you average, but what does it tell you? What does it mean what is deviation? That's where we got to be able to find that connection. Okay? So what we're going to talk about first is the range. This is the simplest one. You guys have it on your piece of paper, so go ahead and copy this down as I do that. The range is the difference between the greatest and least value. But what does the range tell us in statistics? Okay? By giving the difference between the lowest and the highest score of the data set, it gives us a rough idea of how widespread up the most extreme observations are. It gives no information as to where any of the other data points lie. So it only tells us where we're looking between. In this case, we're looking between 3 and 9. Okay? If I give you percentages on a test, you can go from 0 to 100. The data can be spread out more. We're going to have more of a range that we can look at. Does that make sense? It doesn't tell us where it lies. It tells us where they can potentially lie in the scheme of things. So doing this, what we're going to start out with is, what do we usually start out before we do anything? In order. So let's do that in order for us. We have 3, 4, 6, 7, 9. Easiest way to do that, again, for this type of data set, we don't really need to do that. If we want to express what this means for us on a number line, we can write this out. 3, 4, 5, 6, 7, 8, 9. And our data points are going to lie between that. We're going to have 3, 4, 6, 7, and 9. And all what this really is going to tell us to do is take the largest value, the greatest value, 9, and subtract it from the least, and we're going to get 6. So the range of our values is 6. Do I have 6 data points? No, so it doesn't tell us that we have 6 data points. It tells us what numbers it can be. In this case, we start from 3. The range starts from 3 to 9. There's 6 values between those numbers. Yes? A dot plot. We're going to be doing that today as a basic way of looking at things. But you're exactly right. This is dot plot. Are we okay with that? Cool? Okay. So the range is something that we should know. We've done this with parabolas. We've done this with a bunch of stuff. But this is meaning a different way in statistics. It tells us how roughly spread out. It tells us the spread of our data. Okay. Now, looking at this next part here. That's for the first part, yeah. That's easy. That's why I'm trying to. That's the for range. Now, this next part, please pay attention to this. The mean absolute deviation is a way to describe the variation in the set data. The mean absolute deviation, I'm going to also refer to this as the MAD, helps us get a sense of how spread out the values are, how spread out the data points are. Now, right now it might not make sense, and I get that. We have to put context to it so we can understand what we're doing here. The larger the MAD, the further the way that the numbers are to the mean, meaning the more spread out the data points are. And again, you're like, that doesn't make any sense to me. We'll make sense of it. The formula we are going to use, this might look crazy. Does anyone know what this little E looks like? What is it called? Sigma. What does sigma stand for? Adding. Do you remember doing this in sequences and series? Can you tell me what this X with the bar over it is? Remember? No. No, what is X hat from your X bar? We just wrote it down yesterday. No. Yes, but what is it? No. This, I'm sad. This is the mean. It's a mean. We did. We did. I know we did. You guys are my last class. Yeah, you don't want to do underneath. Okay, this next point here, what this x of I tells me we're going to do here, this is the data points. These are just data. So we're going to find the sum of the data, okay? Divide that by how many points we have. That's going to give us our mean. We're going to take the mean, and we're going to take that original data point, subtract them, find the absolute value. And then can you tell me what this n is? What is this n? Numbers we have in the data set. Numbers, data points. This equation might look a lot harder than what we're actually going to do. And the steps here is what we're going to follow. We're going to calculate the mean. We're going to calculate the distance between each data point and the mean. We're going to add the distances together, divide it by the sum of the number that we have. So if you follow this, it'll be very straightforward. Again, we want to make sense of this. Why are we doing this? What's the purpose of this? We're finding the average distance the points are to the mean. This will tell me how far spread out the data points give me. Again, you're like, Mr. Aguilar, just saying words. I'll make sense of it. And then you're like, you look at me like, let's make sense of it. Problems down below. So we're going to do a problem down below here. This is going to make sense of it. Go back. How? You guys are, I don't, you there? You got it? Come on, guys. I didn't copy down that much. You guys have everything copied down. Here we go. Let's make sense of this. We already have them somewhat in order, and it's okay if they're not in order for this, but what's the first thing that we can find out? The first thing it tells us to do is to do what? Step number one. Find the mean. So let's find the mean of our number points. We're going to say x hat, or x bar in this case, is equal to 2 plus 2 plus 4 plus 4 all over, how many data points do I have? 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 4 is 12, 12 over 4 is 3. So the mean is 3. Hold on, please. Trust me. Okay, that's the first part. Now let's try to make sense of this. What does the mean tell me? The average that I have between my numbers. So if I'm on a number line, let's plot the number line here, 0, 1, 2, 3, 4. We can do that. Let's plot our data points and the mean. Our data points are going to be, we have 2, 2, so 1, 2. And we have 2 4s, 2, 2. The visual of what we're doing. The mean is between these numbers, right? This tells me the average between all those numbers. This tells me that the mean is 3. Is 3 a data point? No. It tells me the average of what I would roughly get. Even though the point's not on there, we're going to try to find it. So we understand that it's the average of points. It's the middle number. It's the accumulation of what we can roughly get if we do get this data set. The next one we got to be able to talk about is the math. And here's what we're going to do. We're going to take a data point. So we're going to do this. We're going to do the absolute value of a data point minus the mean to every single one of those. And we're going to add them up. We'll make sense of it. You'll see. Don't worry. So here's what we're going to do. Give me a data point. What's one of my data points? What's my mean? So we're going to subtract 3 for one of them. Yeah, it'll make sense right now. We're finding the distance. We're finding, yeah, it's absolute value, right? Plus, give me the next data point. 2 again. Just go in order. Minus 3. And we're going to do that to all of them. The next one will be 4 minus plus 4 minus 3. Now, what do these numbers tell us? Again, we're finding the distance the points are to the mean. So what is 2 minus 3? Negative 1. What's the absolute value? 1. Which should make sense to us because if our data point is 1 here, how far is 2 to 3? It's only 1 distance away. What's 2 minus 3 for the next one? Still 1 away, which means that we're still 1 distance away from the mean. What about 4 minus 3? 1, absolute value of 1 is still 1. Same with the other one. We're getting the distances all equal 1 distance away from the mean. Now what we're going to do is we're going to find the average of those distances. So what we would get here is we would do 1 plus 1 plus 1 plus 1. We're adding them all up. How many numbers do I have in my data set? So 4 over 4 tells me it's only, so the MAD, the mean absolute deviation, is only 1 unit away from the mean. Smaller the mean, the closer the data sets are. And it should make sense to us. They're all only 1 part away from the mean. If we had a number that was larger, let's say 4, the MAD was 4 for us, that would mean that the data points are more spread out from the mean. That means it's not a good average for us to use as a way to represent our numbers. If half the class has 0 and half the class has $50, half of the class has $100 in their pockets, the mean between them should be 50, right? But does that represent the data? No, because you either have 0 or 100. The spread of it is too far for us to conclude any data using it. We would use it as a method, but it wouldn't really help us out enough. So let's use the same idea and solve it for the one to the right. Let's see if it changes up the way we look at the MAD. We should assume that if the data points are farther away from the mean, we should get a larger MAD. So let's do the same thing. Let's find the mean. Oh, you can if you want to. You don't need to. Let's do that. Let's do that. I don't mind doing it. Should be the same. Exactly. 1, 1, 4, 6. That's fine if you want to do it that way. I'll leave it at that.
You're not adding the 2 middle together.
You're adding them all up. I know. 4 plus 6 is 10. 10 plus 2 is 12. 12 divided by 4 is, so still the same mean, right? Our mean is the same exact thing this time. We're gonna say no. Let's do the same number line, right? Let's try to assume that we're doing the same exact thing. So this will be 0, 1, 2, 3, 4, 5, 6. Right? Yeah, same. Yeah, be different on our number line. Our points for us, if we had to graph these points out, we have 2 1s, 1 4, and 1 6. Our data points, dot plots, right? The mean will still remain in the middle of our values here. This tells me the average for all those values. Looking at those, are all our points about 1 away from the mean? Are all the distances about 1? They're a lot larger, right? One of them we have 3, 1, 2, 2. So that's what we want to be able to see to gather our data. We're going to take the averages of those distances to determine the map. Yes? Yes, absolute value helps. Yes. this is a visual representation. You're not going to do visual representations. You'll see in the next example. I see what you're getting at. Like, can you just jump there if I already have that out? It would be no, but in this case, the next problem, it'd be a little bit harder to find those numbers out. That makes sense. Okay. How many numbers do I have in my data set? 4. Average. Add up the numbers, divide out how many numbers. Good question. Here we go. Let's find the distances between them. So we're going to do the absolute value of what's my first number? So we're going to do 1 minus, what's my mean? Minus it. Always, always, always. Plus 1 minus 3. Plus 4 minus 3. Plus 6 minus 3. What do all these data points tell me they are? So from 1, how far is it away? What's 1 minus 3? Negative 2, the absolute value of negative 2? 2, so it should make sense that this is 2 units away from that mean. What about the next one? It still should be 2, right? We're still looking at 2 distances away. 4 minus 3 is 1. We're 1 distance away from the mean. And then to 6, we are 3 of them. So we have 1 and 3. Again, I'm trying to show you the visual representations of what they mean for us. If we add up those numbers and divide out how many we have, we're going to get 2 plus 2 plus 1 plus 3 divided by how many numbers? We'll take the average of those. We're going to have 8 divided by 4, which is, so the MAD is 2. Our numbers are further out from the mean. They're more spread out. And this is only a basic case, right? Majority of our numbers should be within the MAD of our numbers. So what's our mean again? 3. What's the MAD? So what's 3 plus 2? So 5. Our numbers should be between there. What's 3 minus 2? Again, adding and subtracting the mean values and the MAD, right? Not to say we need to do that, but it's just saying majority of our numbers should be within the average of those numbers. You don't need to do it. I'm just asking you for the MAD. I just want you to try to understand a little bit clearer. You don't need to. Don't do it. Don't do it. Does that make sense? The MAD tells us the spread out of our data or our data points. Is that okay? The farther they are away from each other, the larger the MAD will be, the more spread out our data points will be from the average. Okay? Well, yeah, I'm fair enough. Yes. Choose any point. Any point. Take the point, subtract it from the mean, absolute value. Take the next point, subtract it from the mean, absolute value. Take all those, every single one of them, add them up together, divide out by. No, it's just telling us the distance they are away. Not that it's that we're going negative that distance, it's telling us how far they are away to the mean. Okay, here we go. This is another interesting case here. So copy this down. I'm sorry, you already have this down. I'm just kidding. So you're paying attention. Sorry. You don't need to copy it down again. What is the range? So let's kind of finish this up because we're only going to do these two today. Tomorrow we're going to do variance and then the standard deviation. Similar kind of setup, but a little bit different. Looking at this here, what's the largest value? So in this case, the table lists the test scores of random sample of 8 students who are taking the same math class. It should say find the range and the mean absolute deviation. This is what we're doing for the question. I'm sorry I wrote that wrong. What is the largest value? Oh. So we have 95. What's the smallest value? 78. Subtract them, what do I get? This tells me how spread out my data is on the 8 students. Okay, that's not the mean, that's not the standard deviation, this is just the range. These are all the different values those numbers can take on. No. It just tells me the number of data is in between them. Okay, the range only tells me the values it takes on. If I took another sample, let's say I had a 95 and 90, what are the numbers between those? Between those two numbers, I only have 5 data points. So the majority of my students are going to be a lot closer in the spread, in the range that we're asking them versus the other. Again, it's the data points that it can take on. Not necessarily that we have, it's what those data points will be between. The larger the range, the more spread out the numbers can be. The smaller the range, the smaller the range will be, the smaller the spread will be. Meaning the more clustered points we're going to have. What's our first step in solving this? We don't need to for this case. We have to find the mean. Add them all up, divide up by the number we have. It is 84.25. 84.25. So I'm going to add these up here. It's possible, right? It's possible for us to have a decimal. It's telling us the averages between the numbers. Dividing out by how many numbers do I have? You should get a number that is 84.25. It's the sum of all those numbers, sum over the total amount of numbers we have. Done. This is the answer. This is the mean so far. Oh, you're asking for the sum of, oh, my bad. My bad. 674? Is that what you got? 674? I'll write that out. My bad. Jeez. 674 divided by 8. My bad. I'm like, it's addition. It's addition. Now, with this one, what's bad about these data points and doing this now? It's going to be big. So, to do the mean derivation, just to do a couple of them if you want to, what I'd be doing is taking each data point now. No, take each, no, I wouldn't even count. We don't need to draw this out. So I'd take 86, and I'm subtracting it from the mean. What's my mean? 84. So that's one of them. What do you think we have to do? So you can do that. I'm going to do this for all the rest of them. So this will be 78. You see how many points we have to do? We're not going to draw for this one. We're not going to have to draw for this one. The next one's going to be 95. Absolutely. That's the first 3. You can, again, think about it. You're going to have to do this 40 times. 40. Because of your data points. I'm going to ask you for the MAD. Yes. You got some work you got to do. The next one here is going to be yes. Every single one of them.
Is there a faster way?
Stop complaining, just fine. Or as my fellow students used to say, just do it.
So there's no faster way to do what you're doing right now.
There is on a calculator.
But we do need to show this what kind of text.
The numbers that you're going to be given are going to be a lot smaller for you to do. So don't freak out that it's going to be hard. No. Yeah, you need to make sure you have the absolute value. The absolute value button is right above the division sign, right underneath shift. ABS. It's right up above here. You should be able to see it. ABS. Okay. Adding those up, absolute value. So I'm going to do this really quick. 86 plus absolute value 78 minus answer plus how many numbers we have over the total amount of 8. Yes, 95. So I have 3 of them. 83. Every single time. Because I'm losing some of you guys. I hope not. I get a total number of 30.5. No, that's not what you got. That's the total. We would divide them up by how many? We would divide it up by, so the MAD would be those. Dividing them out by 8, we get 3.81. So the MAD yes. No. Don't shit. Oh yeah, it'll work. That's what I do. Yeah. Roughly, it should be okay. Now, let's talk about what this MAD gives us. Let's talk about what this MAD gives us. This tells me between the 8 scores that I have here, between the, not the median, the average, if our average was an 84.25 between these 8 students, the average of those averages, if you want to think of, is only about 4 points away. Is that pretty close for a test score? Pretty close. So roughly within 4 points of each other. That might be one question they would have messed up. Right? Super, it's close. Cheating close, is that what you said? Maybe. Right, but let's say the MAD was 10. Right, then we know that the numbers are further spread away from each other rather than being closer to the mean, right? If it was 85 and they were 10, the MAD was 10, hypothetically speaking, that would tell me that the numbers are further away from the mean than our average tells me. Meaning that the average isn't a good indicator of what we're going to do. Does that make sense? Yeah? And that's all what I wanted you guys to do for today. Range and MAD. Mean absolute deviation. Is that okay? Can I clear it? So, the bottom one down here, this bottom one down here is what you guys want to be able to put into both homework and your Booklets. It's homework and booklets. That's why, yes, that's why I'm leaving it. So, huh? It's really the whole thing. You can write those in if you need to. Huh? Yeah, if you need to put them in. I mean, sure. Whatever you need to cut out. Does that make sense? Okay. So solve for that. Take care of it. Tell me what the mat is. Erica enjoys posting pictures of her puppy online. Here's how many likes she has in the past 6 pictures she received. Maybe we want to see the mat just to determine on average how many more or less that she get per picture. No, I don't. I'll try to see if I can do it. Okay. Just tell me what the range is. It tells me how spread out the numbers are in your data.